Hi, my name is Patrick Reagan. This video called RAID covers a redundant array of independent disks to provide better performance and fault tolerance. RAID often found on servers, storage area networks, and even some gaming computers that want faster performance. For those who are going to take the A+ exam, there are practice questions toward the end of the video. If you like this video, make sure to select like, and if you have not, subscribe to the Pat Has Your Back channel. Redundant array of independent disk, or RAID, also known as redundant array of inexpensive disk, is a type of storage that writes data across multiple drives within the same system. Different configurations are expressed as numbers such as RAID 0, RAID 1, or RAID 5. Each RAID type gives users different benefits, including increased performance, greater fault tolerance, or a combination of both. The most common types of RAID used today are RAID 0 striping, RAID 1 mirroring and its variants, RAID 5 distributed parity, and RAID 6 dual parity. While most forms of RAID offer fault tolerance, this is not a replacement for backups. The most common form factors are shown on the screen. RAID 0 striping, RAID 1 mirroring, RAID 5 striping with parity, RAID 6 double parity RAID, RAID 10 combines mirroring and striping, RAID 50 combines striping with parity and striping, and RAID 60 is double parity RAID and striping. These are not the only forms of RAID, but by far are the most commonly used. Some large enterprise environments may use RAID 01 and RAID 50. RAID 0 disk striping spreads the blocks of each file across multiple disks. Since you're spreading the reading and writing of data over multiple disks, it's the fastest of the RAIDs. However, it is not fault tolerant. One failed drive will cause the entire array to break. It requires a minimum of 2 disks, but if you add additional disks, you'll get faster performance of the RAID. RAID 1, or disk mirroring, duplicates the data on 2 drives. Disk duplexing is taken the next step, which ensures that the drive is connected to a different cable and adapter in case if the cable or adapter fails. When data is written, it is written to 2 drives simultaneously. While writing is not faster, read performance is increased as it can read from either drive. Since you're using 2 drives to store data, capacity is only 50% of the independent disk drives. If one disk goes down, you keep functioning. To recover from failed disks, you may need to break the mirror, replace the drive, and re-establish the mirror. RAID 5, striping with parity, splits data into groups across all available drives. One of the drives holds parity information for the other drives. Parity information is distributed across the drives. There is no dedicated parity drive. It allows for a single disk failure. If one drive fails, it can use the parity information to reconstitute what was lost on the failed drive. It has increased performance because all drives are reading and writing data. It is slightly slower than RAID 1 since it has to calculate parity information, but it balances data protection and performance. It requires 3 or more drives. RAID 6, or double parity RAID, is a storage configuration that distributes data across multiple disks and writes parity data to protect against data loss from disk failure. RAID 6 uses a dual parity method to calculate 2 sets of parity data for each piece of data written. This allows RAID 6 to continue operating normally if 1 or 2 disks fail, even though the array is operating in degraded mode. When data is read from a failed disk, the array controller recalculates the data. If more than 2 disks fail, data must be restored from backup media. RAID 6 requires a minimum of 4 hard drives, and the maximum of disk units in a parity set is 18. The total available storage capacity in a RAID 6 configuration is the sum of the capacities of all the drives minus the capacity of 2 parity drives. RAID 6 write speeds are slower than write speeds on a RAID 5 configuration. The reason is double parity requires additional calculations, whereas RAID 5 uses single parity. RAID 5 rebuild times tend to be quite a bit faster, ranging from 50 to 200% faster, depending on capacity, RAID controllers, and the amount of data you have. The double-digit forms of RAID, like RAID 10 and RAID 50, are nested RAID configurations that combine 2 or more RAID levels to achieve a specific balance of performance and redundancy. They are implemented by layering one RAID level on top of another. RAID 10 is a nested or hybrid RAID, sometimes expressed as 1 plus 0, that is the stripe of mirrors or nest at least two RAID 1 sets with the RAID 0. It offers high reliability and performance. The biggest benefit of RAID 10 are the performance of each set of stripes adds a multiple for read and write. It's the fastest RAID with redundancy. A RAID 10 of 6 drives has a potential max read increase of 6 times and a write increase of 3 times. You can retain your data even if you lose up to half your disk, provided your mirror copy does not fail. Recovery after replacing drives is very fast since it just has to copy data from other drive of the mirror set. It requires at least 4 drives. Disadvantage of RAID 10 is you lose up to half of capacity. Here is a larger layout of RAID 10. RAID 50, also called RAID 5 plus 0, combines the striping of RAID 0 with the distributed parity of RAID 5. RAID 50 configuration requires a minimum of 6 disks. It can tolerate 3 maximum potential simultaneous drive failures, but only 1 per RAID 5 set. Because the reliability of the system depends on a quick replacement of the bad drive that the array can rebuild, it is common to include hot spares that can immediately start rebuilding the array upon failure. However, this does not address the issue that the array is put under maximum strain, reading every bit to rebuild the array at the time when it is most vulnerable. RAID 60 combines RAID 0 striping with RAID 6 distributed double parity. It requires at least 8 disks. It can withstand the loss of up to 2 disks in each parity set. It provides the most redundancy shown in this presentation and offers moderate performance. RAID 0 will only be used if high performance is necessary in non-critical environments such as temporary storage and cache servers. RAID 1 and 5 are common for servers that require fault tolerance and are considered the minimum for production servers. For some performance critical applications or maximum fault tolerance may use RAID 6, 10, 50, and 60. RAID 5, 6, 10, 50, and 60 are common in storage area networks or SANs. For large enterprise SANs that require high levels of fault tolerance, you will find 6, 10, 50, and 60 are very common. Here's a table showing the RAIDs. The fastest RAID type is RAID 0, followed by RAID 50. RAID 60 offers the best fault tolerance, followed by RAID 10 and 50. There are many RAID calculators available on the internet. If you want to see how disk usage compares with the various types of RAID, visit the site shown on the screen. Hardware RAID uses specialized hardware such as a RAID controller card or adapter, or can be built into the motherboard that runs independently from the operating system. It is transparent to the operating system, although it may require special drivers to recognize the drives. It offers better performance, but costs more than software RAID. Some hardware RAID can have designated spare drives, which can automatically replace failed drives used in RAID. Software RAID is managed by utility software within the operating system. Performance is slower and cost is lower than hardware RAID. Replacing a failed disk is usually a little bit more complicated. You should follow these steps when troubleshooting RAID. Step 1. Identify RAID types so that you know what the expected behavior, including fault tolerance and how it reacts to failure, and find the documentation for the specific RAID implementation before you start reconfiguring RAID and pulling drives. Step 2. Check logs and alerts via the RAID controller BIOS or UEFI and the related software that comes with the RAID, and/or check the OS system logs. Step 3. Check for common symptoms and their cause. Missing failed disk indicates drive failure, loose cable, or bad port. Degraded array indicates one or more disks failed or removed. Rebuild takes too long indicates a disk health issue or I/O bottleneck. RAID not detected or found indicates a controller failure or disabled port. OS won't boot indicates a failed RAID 0 or corrupt metadata. And data inconsistency or corruption indicates controller failure or power loss. Step 4, hardware inspection, where you reseat or replace suspected failed drives, check cables, SAS and SATA connectors, backplane, and power. Use smart diagnostics including Linux Smart CTL and Windows Crystal Disk Info. Step 5, use RAID management tools based on your RAID controller. Step 6, rebuild or replace RAID. Replace failed drives if redundancy exists for RAID 1, 5, 6, and 10. Start automatic or manual rebuild. Monitor rebuild progress to avoid I/O overload. Step 7, if the RAID is degraded but accessible, back up immediately and avoid powering on or off repeatedly as it could cause further failure. Step 8, advanced recovery if needed. Use RAID recovery software and/or engage a data recovery professional if RAID metadata is corrupted or if multiple drives failed in RAID 5 and 6. Question: what RAID provides the best performance? Answer: RAID 0. Question: which RAID is called disk mirroring? Answer: RAID 1. Question: which allows you to have one drive fail without losing data? Choose all that apply. Answer: RAID 1, RAID 5, and RAID 10. Question: what allows you to establish fault tolerant disk in a server? Answer: RAID. Question: which of the following allows for multiple failed disks? Choose all that apply. Answer: RAID 6 and 10. Question: you need to upgrade a key enterprise application server that is currently running RAID 5 that cannot have any unscheduled downtime or data loss while keeping performance high. What would you recommend? Answer: RAID 10. Question: which RAID uses parity? Answer: RAID 5. Question: which RAID is double parity? Answer: RAID 6. Question: how many disks can you lose in RAID 6? Answer: up to 2. Question: you're building a new application server. Which of the following RAID levels provides maximum performance and redundancy? Answer: RAID 10. For more information, refer to these sites. In summary, redundant array of independent disks, or RAID, is a type of storage that writes data across multiple drives within the same system to increase performance, greater fault tolerance, or a combination of both. While most forms of RAID offer fault tolerance, it is not a backup. RAID 0 or disk striping offers the fastest performance by spreading the blocks of each file across multiple disks. It is not fault tolerant. RAID 1 or disk mirroring duplicates a drive. RAID 5, or striping with parity, splits data into groups across all available drives to increase performance, and uses parity information for data protection. RAID 6, or double-parity RAID, is storage configuration that uses the dual parity method to calculate 2 sets of parity data for each piece of data written and allows 1 or 2 disks to fail. RAID 10 is a nested or hybrid RAID that nests at least 2 RAID 1 sets with RAID 0 to offer high reliability and performance. RAID 60 provides the highest redundancy. Thank you for watching this video. The next video will be Storage Devices, Part 8, Troubleshooting Drives. If you like this video, make sure you select like, and if you have not already, subscribe to the Pat Has Your Back channel. Thank you.